The IB steam trap is a continuous drainage, intermittent discharge device that operates on the mechanical principle. The heart of the inverted bucket trap is this bucket. In the inverted position, it acts as an open float. It is capable of functioning under very high pressures because the same operating pressure is exerted both inside and outside the bucket. A small orifice called a bucket vent is located at the top of the bucket to ensure that non-condensable gases cannot be trapped inside the bucket. Steam, air, and condensate enter the trap through an inlet tube beneath the bucket. Air and condensate are discharged through an orifice at the top of the trap. At the orifice is a valve that is linked by a lever to the top of the bucket so that the valve is closed when the bucket is in the up position. The body of the trap is a cylinder which contains the bucket. During proper operation, this cylinder is always filled with condensate to a level above the top of the bucket. This condensate provides a constant water seal above and around the bucket, preventing live steam from escaping from under the bucket. Finally, in the cap of the body is a space above the water seal where any non-condensable gases which have passed through the bucket vent will collect while the valve is closed. Incoming steam is trapped between the top of the bucket and the water seal below. When approximately 2/3 of the volume of the bucket is filled with steam, the bucket becomes buoyant and floats to a point where the valve is pushed toward the orifice by the bucket clip extension. The higher condensate velocity near the orifice propels the valve into the seat, where it is sealed and held shut by differential pressure. Radiation causes the steam inside the bucket to cool and condense. If the condensed steam is replaced by more steam, the bucket remains buoyant and the valve closed. However, when enough steam has been condensed by radiation and is displaced by entering condensate so that only 1/3 of the bucket volume contains steam, the bucket loses buoyancy. As more steam condenses, the bucket becomes heavy enough to pull the valve off its seat. With the discharge valve open, condensate flows down around the bottom of the bucket and out through the discharge port. Air too rises to the top of the bucket, where it flows through the bucket vent and water seal, accumulating at the top of the trap. When the valve opens, the air is pushed out of the trap ahead of the condensate.